Hello, my name is Juan Vargas. I study electrical mechanical engineering. My topic is about fastest light pulsation electron are sunlights. Definition: pulse or lights. Optical pulses are flash or light, particularly very short line pulses are often generated with laser. Laser pulse and delivered in the form of laser beam AA, with a highly directional radiation. Electron. An electron is a negatively charged subatomic particle. Electron is an atom existing in a spherical shell of various radius. Represented energy levels are much smaller than the nucleus of the atom. In electrical conductors, current flow results from the movement of electrons from atom to atom individually and from negative to positive electric pole in general.
How fast does an electron move down a wire? Which would win in a race, an electron or a snail? Let's answer the second question first. You may be surprised to learn that the snail would win, easily. Let's use this electrical circuit as our racetrack. It has an on-off switch, a battery, and a light. The distance around our racetrack is 22 inches. According to the 1999 World Almanac and Book of Facts, a garden snail can move at a whopping 0.03 miles per hour. That's 0.528 inches per second. We'll call her Joan. The 1998 Guinness Book of World Records says that a garden snail named Archie went a whopping 13 inches in 2 minutes. That's 0.108 inches per second. This is Archie. And here's our electron. We'll talk about how fast it moves later. And they're off. Archie and Joan roar ahead with the electron. Well, it's moving, but doesn't look like it yet. Joan's in the lead, and Joan zooms ahead with Archie behind, and then the electron... Well, this will take all day, so let's fast forward it. And the winner is Joan, with Archie well behind, but our electron has moved a mere 1/10 of an inch. But doesn't electricity move at the speed of light? The speed of light is around 300,000 kilometers per second, or 186,000 miles per second. Actually, in an unshielded copper wire like this one, electricity moves at around 96% the speed of light, so 178,560 miles per second. At that speed, ignoring other losses, electricity could circle the globe over 7 times in just 1 second. So electricity moves at close to the speed of light, but the electrons don't, as we saw with our little racetrack. One way to visualize what's going on is to use this row of marbles. When we push on one marble, the effect of that push is passed on from marble to marble, and the result is felt by the wooden tile almost immediately. The individual marbles represent individual electrons. They don't move very far along the way. Electricity is represented by the effect on the wooden tile. That effect is passed on almost immediately. And to answer our other question, how fast are the electrons moving? The electrons move at a velocity called the drift velocity. Here's one easy formula we can use to find out. Calculating it out, we get 0.0007 meters per second, or 0.0028 inches per second. Remember, our slowest snail, Archie, goes 0.108 inches per second, 38 times as fast as the electron. For the electron to go around our 22-inch long track, it would take 7,857 seconds, or around 131 minutes, ignoring the time spent in the battery, switch, and light. Electricity from a battery is direct current electricity. The electrons go around in one direction. Electricity
Application in telecommunication. Optical fiber is used by many telecommunication companies to transmit telephone signal, internet communication, and cable television signal. Fiber optic communication is a method to transmitting information from one place to another by sending pulses of infrared tone on optical fiber. The line and flow of carried by that is modulated. To carry information, fiber is preferred over electrical cabling when high voltage, long distance, or immunity to electromagnetic interference in required. This type of communication can transmit voice, video, and telemetry tones, local area networks, or across long distance.
Decade fiber optic to used widely for telecommunications. It would eventually supersede copper cables for many uses. But why? Fiber optic cables use pulses of light generated by an LED to transmit data along strands of glass or special plastics. Copper, on the other hand, relies on the transmission of electrical currents along its length to perform the same function. Data is transmitted on copper cables as electrical pulses. A detector receives and decodes the signal. However, the longer the signal travels, the more it deteriorates. This is a phenomenon referred to as signal attenuation. With fiber optic cables, the transmitter converts electronic information into pulses of light. The pulses are given in a binary system, with one pulse equating to a 1 and no pulse equating to a 0. When these light pulses reach the other end of the cable, an optical receiver converts the pulses or lack of pulses back into electronic information. So far, so good, although it might be important to understand what is meant by faster when comparing the two. When discussing the relative performance of either fiber optics or copper wire, the term faster is a little deceptive. Both fiber optic cables and copper wires transmit data at speeds slower than the speed of light in a vacuum, though some recent developments in fiber optics have managed to come closer to the speed of light. Yet either copper wire or fiber optic speeds could, in theory, transmit data around the Earth several times a second.
Advance and disadvance. Advance. The CAN stimulus transmits a great deal of information with two optical fiber 60,000 telephone conversions. Can be held simulation with a fiber optic cable 6 million communication, while with a copper cable only 500. They are buried in a fiber optic cable as much smaller diameter than a copper cable with the same transmission capacity, so it can easily add to existing fallacies where there are already cables. For example, in the cable 2 tan ascending buildings, they are legend compared to metal cable. They do not conduct electricity. Therefore, they use free and electrical hose. They transmission information safer, while satellite or radio communication signal can be easily interfered with. Signal transmits with optical fiber are not easily interfering with. In addition, possibly interfering in easily detected by an optical signal detector. This advance is very important to maintain the confidence on information. They last a long time. They are not affected by external conditions such as temperature and humidity. They can even using under cable. They are not damaged by short circuits or electrical sources. They are compatible with digital technology. Disadvantage: they need converters in order for optical fiber to transmit the signal. A converter must transform it from electrical to luminous. When it raises its destination again, it must transform into an electrical signal. This conversion makes communication more expensive. They are fragile. Not actually repaired in cars, fiber optical cables in demand, especially personal, are required to repair. Have a high installation costs. Is some applied in Ecuador. In Ecuador, fiber is being used considering the deployment as an engine for the achievement of several objectives, and thus promoted the quality of telecommunication service to the benefit of Ecuadorians. Ecuador today has 45,000 kilometers of optical fiber. which covered the country compared to 2006 when we are handling 3,500 kilometers. With the waterfront, also the bulk internet in the country, it has been possible to answer the Ecuadorians have access to quality information and the value service provided through this platform, such as education, health, government, etc. In addition, the growth in optical fiber contributes in several other sources as the dynamism of the economy, the boost to innovation, the contribution to GDP growth, the increase in cooperation rate, among other advances which are necessary for the integral development of society. These services are used by children, young people, and adults who, for example, are already connected to the internet to carry out their tasks, to line to the network from their cell phone, to carry online transactions, to buy or sell products, among other activities. Thanks to fiber optic are possible grounds the connection.
In Ecuador, for the year 2006, fixed internet service was able with dial-out technology and a speed of 128 kilobytes per second. The cost of the basic plan was $39.99. During the last 5 years, progress in advance in the change of ADSL networking to the fiber optic. The basic plan provides a speed of 3 megabytes at a cost of $18, which means an increase of 24 times the speed and reduction of the fee to more than 50%.
Conclusion: the pulse, online and optical fiber allow a breakthrough in telecommunication little by little have replaced the copper cable as it gets a wide passage size. Thank you for attention. See you next video.